Good to see you. I am Kamal Sarma. Today I am going to discuss about static indeterminacy. This is, if I write it down, it is static indeterminacy. This is today's topic. But when you say static indeterminacy, there is another kind of indeterminacy that is called kinematic indeterminacy. There are two types of indeterminacy. One is called static, another is kinematic. Kinematic is related to forces. It relates to forces, unknown forces in a member or in a frame, in a beam or in a truss. The kinematic indeterminacy is related to deflection. So, I told you earlier, there are two kinds of procedure to find out the unknowns in a structure. These are, one is force, which is unknown, forces in the members, and the reactions developed in the structure. And other one is the deflection. This deflection may be linear deflection or it may be angular deflection or deformation, whatever you call it. Now, our discussion is not about kinematic indeterminacy, today's lecture, because I don't like to mix them, it will take time. So, we will discuss this later, not today. But the static indeterminacy is very useful for finding out whether the structure can be solved by hand or not, or by some other extra procedures. It determines how can you find out the forces in the member. What if it is easily determined? If you can easily determine the forces in the member, it is called determinate force structure. Determinate structure, you should know the determinate structure and indeterminate structure. Determinate structure. The other one is indeterminate structure. So, determinate structure, you can easily find the forces in the members in the structure. The indeterminate structure, it is not that easy. Okay, this is the difference. Another thing in our discussion today, we will be only considering plane frame or plane truss. Plane frame. Our discussion will be plane frame. First is and beams, and plane truss. You know the difference between the frame and truss, right? The frame you can have moment, shear, torsion. No, not torsion. Torsion is a, you can consider torsion also, but our focus is the axial forces, moment, and shear force. Okay, the plain truss is you have only axial forces, tensile force or compression force. These are the two forces on the plain truss. But before doing that, we need to have the support conditions. Okay, so support condition, if it is a beam, if it is a hinge, and this side it is roller supported, this type of structure is called simply supported. Why simply supported? It has got vertical, if it is A point and this is a B point, so VA is the vertical reaction there and HA is the horizontal reaction there. Here only vertical reaction, which you can say VB. If the force is something called P may be anything, 10 mega Newton or 5 ton, anything. So if it acts at an angle of theta, then you can find out the reaction. This is the simple beam, simply supported. Why you can find the three reactions? That is because we have got three equations. Summation of m is equal to 0, summation of f is equal to h, f v equal to 0, and summation of f h is equal to 0. These are three equilibrium equations we have for plane frame or plane structure. Then what is the plane frame or etc.? It has got two dimensions. This is like a board. This board, it has, you can have two axes. One is your x-axis, another your y-axis. If you determine, and the third axis, this side is absent. You can see you do not have anything on this direction. So this axis, that's called g-axis, is not there. So it is xy plane only. So plane frame, plane truss, beams, etc. all have two dimensions, x and y. Got it? So that is the region. We have three equations and three unknowns. These reactions, the P is known, is given. But these reactions you have to find out, and that too very easily. It is three equations that are there. Three equations of static equilibrium. Okay? So that is, this type of structure is determinate structure. This type of structure is a determinate structure where you have only three unknowns. But in the beam, we can easily find out the bending moment and the shear force once we know these reactions. In a beam, always we have two unknown, two forces, with the bending moment and shear force. We discussed that in our last lecture or previous lectures. Shear force always act a vertical force transverse to the beam. A moment is, it's a bending, rotation, something like that. Try to bend it. And shear, what the shear action? I told you the shear is something like shear it like that. So these two bending moment shear force we can easily find on the beam. So this is a determinate structure. What is indeterminate structure? In a simple form, suppose we consider the beam. So if you have a beam like this, if you have a beam which has got the hinge, let us do one thing. We have a beam like this. It is pin jointed. This is also pin jointed. This is the pin supported. So here the reactions, this one and that one, 2. Here also reactions, 2 reactions. We have got VA, VB and HA and HB. So 4 unknowns, and we have got the 3 equations. In ordinary cases, we cannot easily find the 4th unknown. So this is the indeterminate structure. So as because there are 4 unknowns, you multiply by 3. 3 can be calculated, 3 can be found out, but not the 4th one. So it is 4 minus 3 is 1. The degree of indeterminacy of this beam or the structure is 1 degree, 1st degree indeterminacy. That is called indeterminacy. What is the degree of indeterminacy? Means how many unknowns you cannot find by using the 3 static equilibrium equation in simple way. So if the number of unknowns more than 3, that is your degree of indeterminacy. Okay, got it? So there is there is a thing, you know that sigma m equal to 0, sigma v fv equal to 0, sigma h is equal to 0, 3 equations. That means it doesn't mean that you have got a 3 reaction means that it is a stable. This is not true. There are 2 exceptions. One is if the reactions are parallel. That means if you have a roller support there, in a beam and another roller support there. So this is reaction is there, reaction is there, reaction is there. 3 reactions, right? But do you think this is stable? No, it will look like a skateboard. It will moving that way. Okay, so this is not a stable structure. That means if the reactions are parallel, then this condition doesn't satisfy. That means it is not, even if you cannot calculate, even if you calculate, it is not a stable structure. It's an unstable structure. Similarly, there is another condition. If the reactions are concurrent, that means they are meeting at a point. If the structure is something like this, this is roller, this is a roller, and this is also a roller. So if you project it, if you project that, and if you project that, if these 3 concurrent meeting at a point, their direction at certain point, this is also not stable. Suppose if you have a force there, P. So P will try to cause a moment at this point, right? anywhere. But anyway, P is got a moment there. But these reactions, if you take moment about that, it has got some value, P into X, right? If it is X, but what is the moment of the other reactions? This reaction on these, they are meeting at this point, they will have a 0, this is 0, this is 0. So Px cannot be 0. When it Px, it cannot resist the moment, it will try to rotate. So this is not a stable structure. If the reactions are concurrent, meeting at a point, these are the two exceptions. There may be another exception which is called if it itself is a collapsible mechanism. If it collapses, then it is not possible. Okay? So 3 unknowns and 3 equations makes the structure determinate. If it is more than 3, suppose there is an equation to determine the forces. It is written like R equal to greater than equal to N. This is the equation. What is R? R is unknown forces and reactions. N is your parts or elements. So N is greater than 3N. See, not only one N, 3 times of N. Then, if it is that, the structure is a stable structure. If it is the case, it is stable. And if your R is less than 3N, it is unstable. I will explain what is N and R. But out of this, the answer, out of this, if R equal to 3N, it is determinate structure. If R is greater than 3N, it is indeterminate structure. If R is greater than 3N and R equal to N is determinate, if R is greater than 3N, it is indeterminate structure. And if R is less than 3N, it is an unstable structure. This is the equation for frame and beams. Frames, plane frame, you can say plane frames and beams. You see, I am not discussing the space frame because it will slightly different. It more parameters coming in on different parameters. I don't like to confuse you at this stage. Reason that we will be solving problems now onward. Bending moment, shear force, forces in the truss. So forget about the space frame, space truss for the time being. We will be focusing more on the plane frame, plane truss, bending moment, shear force of beams, etc. So it is the plane frame or beam condition. This is the condition. Okay. So how to calculate n? R is the unknown forces. It may be the unknown forces. There are two unknown forces. One is the reactions and the support, and member forces. As I told you, n is the parts or elements. Okay, let's see. Suppose, take the case of again the simply supported beam. Okay, we have got a pin joint, we have got a roller support, we have, so we say that it should be the determinate structure, we know that, right? So three unknowns. Our equation is R, which is equal to 3. We have one member, one element. So our n equal to 1. So our equation is that if R is greater than equal to 3 times of n. Correct? So R is 3 and 3 times of 1, they are equal. 3 and 3 times of 1, 3 equal. So it's a determinate structure. Degree of indeterminacy here is 0. No indeterminacy. But suppose we have a fixed end. We have a fixed end. How many reactions are there? One is, if it's point A, HA, vertical is VB, VA, sorry, and there is a moment, MA. Because it try to bend, if you put it that way, it's putting some pressure, you feel the moment here like that, you put some pressure, moment, and that moment is MA. But it is the same thing. If you have some load there, this load you know, meter or feet. W is the unit load, uniformly distributed load, we call it. So there are three unknowns, so we can easily find out. It's a determinate structure. But if we have a roller support there at this end, that means we have got only vertical force. Now you see 1, 2, 3, 4. So your R equal to 4. One member we consider. So n times 3 times 1 equal to 3. 4 minus 3 is 1. So degree of indeterminacy is first degree, or is called first degree of first degree or 1. It is either way it is called. Degree of the indeterminacy is 1 degree. So now we use our general equation. Suppose if you have a structure like this. If you have a structure like this, right? Very complicated, difficult little bit, not the easy structure this time. This is a hinge. I told you end. Can you tell me the end? How many ends are there? Your parts. One thing, I'll show you how to find an end. Before that, I would like to tell you one thing. It's a free body diagram. We should know a little bit of free body diagram. What is free body diagram? Suppose if you have an inclined surface like that, if you have a box there, the box has got a weight, right? And because of this weight, it has a normal force is N, and the reaction force is mu N. So these are the forces. It prevents it from sliding. This is in equilibrium. It's not sliding. The box is not sliding down. It is staying there. The friction resisted the downward movement on this direction. So instead of having this whole thing as a plane, we can draw the free body diagram of this box like this. W, this is N, and frictional force F. So this is representing the whole thing in terms of forces. This is called free body diagram. Similarly, if you cut a member, because in a member you have forces, first force is what? Shear force. They are opposing each other, cancelling each other. The another force is your axial forces. Another one is your moment, right? Three forces acting on this, but they are equal. They are equal and opposite. So if you consider is the FH, FV, this is also FV. FH, this is FH. It's a M1, you can call it M1. Same. So this is a free body diagram instead of saying that. But if you have, what is the unknown here? That is the member unknown. What is the unknown of these reactions here? It is the fixed. It was fixed, right? If you represent it in terms of forces, it will be moment there, particle force there, and horizontal force there. It is hinge. So it will have particle force and horizontal force. The moment part is absent. It is zero because the hinge. It is, take this one is roller support. See, one thing you see, they are not parallel, because you see, this tree may be parallel, but not all are parallel. These are on other plane, and there's a moment is also nothing there. So these reactions are not parallel or not concurrent. So it's a stable structure. Now you see, these are the forces here, and we cut it here same way. So now we are not going to cut here and there and there. We cut only such a way. There's the meaning. I will tell you a technique. The technique is, this member should have at least one support. This part. This part who also have one support. This part should also have one support. If there is no support, so if you cut it somewhere here, try to find out forces like that. If you want to this is not possible because this segment from here to here doesn't have any support. It is not connected to a support, it is free. So this is not the way to go. There must be one support. So we cannot cut it somewhere in the middle. So it is a one support we must have. We have one support, this element or this part, one support. So now count the reactions and forces. Here 3, here 2, this and that, this is 1. But here you have altogether 6, but they are equal to each other. So you, instead of considering both, we will consider only one set, not the other. Ignore the other one. So here 1, 2, 3, because they are equal in magnitude. They are opposing each other because to make it balance. Okay, so there are 3, here also 3. 1, 2, 3. Ignore that part because they are equal and opposite. So we have unknown 1, 3, 2, 1. This is 6 plus 3 plus 3, 9. Your R equal to 9. How many members? 1, 2, 3. 3 members. N equal to 3. Right? So it is, we have an equation 3n. Correct? So your R 9 at this side 3 times 3 9. So 9 equal to 9. This structure is a determinate structure. Got it? Earlier you cannot find out. It's hard, right? But now this structure is a determinate structure. You can find out all the reactions, all the forces in this frame. Again, I am giving you the total view. By looking at the structure, can you tell me, is it a determinate or indeterminate? It's a determinate structure. We found out, we proved it. Got it? This is easy, right? Now, these type of questions you may find in exam, in GATE exam or some other competitive exam. Suppose somebody give you make it more complicated. Find out the degree of indeterminacy of the structure. Okay? So what will you do? See, here you know there will be 3 because it's a fix. This direction doesn't count, doesn't matter. This is roller. Now, I told you earlier that you have to cut it such a way there must be one support. So that means we have to cut here, we have to cut here. So this has a support, this part. So this is second time we cut here and we cut here because we have this takes the another element. It is a support is there. Support must be there. And there is one. Cut it here. This is for the, so you have 1, 2, 3, 4. Your n equal to 4. And every frame member has got a 3 equation. 3 unknowns, sorry. One, two, 3. Here 3, here 3, here 3, here 3. Got it? So your total number of R equal to 3 plus here 3 at the support 2 all this as I saw. It is 1, this is 3. So what is R? 3 plus 2 plus 1, 6 plus 3, 9. 9 from there. Then 12, 15, 18, 21, 24. R equal to 24. Again, 3, 2, 3, 3, 9, 3, 3, 6 plus 2, 8, 17, 18, then 21, 24, correct? R equal to n. Now check what is the R. Now check what is the value of 3n. 3 times 4 equal to 12. Your 3n. So 24 minus 12. This is statically indeterminate by 12 degree. Get it? 3n equal to 12. Total number of unknown is 24. Now, this is the general equation is very powerful, you know. That equation to find out the degree of indeterminacy for beams and frames. Okay? So, R is equal to greater than equal to 3n. Now apply to the beam. Remember we have a beam like that. Prop cantilever. This part is cantilever, prop cantilever, there is forces there. So what we will do, we say that there's one element. Here are 3 equations, 3 unknowns. If I draw it, moment, horizontal, vertical, and vertical. This is the roller support. We know that it is 1, 2, 3, 4, n equal to r equal to 4, n equal to 1. So 4 is greater than 3 times of n. 4 is greater than 3. So 1 degree. Degree of indeterminacy 1. Okay. Let us do our technique, cutting technique. We cut it. Okay. Now we cut it. Because this has got, this part will have this support, this part will have this support. We cut it, then we will have got the, like earlier. So 1, 2, 3, 3, only consider one side. So 3 plus 3, okay, the vertical is 3, 3 plus 3, and there is 1. So our R is 3 plus 3 plus 1, 7, right? What is the member? 1 and 2. Your n equal to 2. Now, 2 member, 2 part. So, 3 times 2 equal to 6. This way also degree of indeterminacy is 1, first degree. So this is how you calculate the degree of indeterminacy. You can do it in exam hall or anywhere. It's easy, right? Okay. Now, in case of truss, slightly different equation we use. We have this truss is something like R plus M is greater than equal to 2J. We'll discuss more in the more in the and when we discuss the when we analyze process. R is the external reaction. Not all the forces. This is number of members. J means you see in truss there is no moment, so you have only two forces, vertical and horizontal x and y axis. So 2J, because of that it becomes 2J. J is your joints, number of joints. If this is true, then this is for truss, and characteristics of truss is it is only axial force. Member forces, if you have, okay, now let us draw a truss. Very simple truss. Right? It is pin jointed, this is roller supported, it is the vertical only, this is horizontal only, this is vertical. This M is here 1, 2, 3, 4, 5, 6, 7. M is equal to 7. Number of the 1, 2, 3, 4, 5, 6, 7. Your J equal to 1 joint. 1, 2, 3, 4, 5. J equal to 5. How many reactions? 1, 2, 3. Here R equal to, this R equal to 3. M equal to number of members is 7. So R plus M, 3 plus 7 equal to 2 times of 5. One thing, this is a equation for stable truss. Okay, the truss is stable. If it is equal, R plus M is equal to 2J, it is a determinate truss. And if it is only greater than, this is indeterminate truss, but stable. This is indeterminate. M is R plus M is smaller than 2J. This truss is unstable. It cannot take the load. So, these are the three equations for truss. Now, one thing you should remember, to be a determinate structure, R must be always 3. Because there are two kinds of indeterminacy. A structure can be determinate internally or externally. And internally. This is the externally indeterminate means, suppose if you have got a pin jointed there, that means it has got a vertical and horizontal reactions. So number of external reactions is 4 and you have only 3 equations. So 4 minus 3 is 1. That is, it is externally indeterminate by 1 degree. Internally, it may be you can find out the forces. But sometimes the structure may be internally indeterminate. Suppose it is something like lot of redundant member. Those members, this type of truss where you have more members are connected, that equation, if you find out what is the indeterminacy, this is a 3 R plus M equal to how much? 3 unknowns. This is 3 R equal to 3. And your M is how many members? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. You may find more, but let us say it is 22. Okay, so your M equal to 22. How many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, probably 12. Count it. I may be wrong. You can find more or less. So now it is, see the equations. 2j equal to 24, right? And M plus 3 plus 22 is equal to 25, right? So it is indeterminate. It is, this side is bigger and this side is smaller. So this is indeterminate by 1 degree. Strange. I thought it will be more indeterminate. But anyway, this is how you calculate the indeterminacy. And that is called static indeterminacy. Indeterminacy means how hard the structure is to calculate the forces in the member. There is a way, the procedure, I will discuss that. This is called compatibility equations, all those things. I will not like to talk it today. I will discuss it today. I will do it some other time, because you should go slow, then you can understand better. And one more thing, I have a request to you. If you give comments on my videos, then I will understand that you like it. If you give a thumbs up, a like button, if you press the like button, if that excites me, that give me idea that you like the video, understand, and that encourages me to produce more videos. I will share with you everything I know. Okay, and including the work I am doing right now, the bridge engineering. I have a plan to do structures, all kinds of structure, theory of structures, then go for design of structures, both concrete and steel, touching a little bit of pre-stressed concrete also. Then we'll be discussing practical examples in bridges and buildings. So this is all for today. Okay, I will appreciate if you give comments and likes, etc. That encourages me and motivates me to do more work. If you do not understand, then what's the use of having all the lectures? Got it? In my class, when I was teaching in Assam Engineering College, students used to ask me, I encouraged them to ask me questions. And I feel good that I am keeping them interested in my lectures. If you like it, if you feel it, you give like button, give comments, how you feel it. If he needs to be improved somewhere, comment it that also, I won't mind. Thank you very much. Have a good day. Appreciate it. Thank you.